Creation and transformation of landscapes on the surface of the earth come back to the first header that we had: time, form, and formation. And landforms are created under two big theoretical constructs: uniformitarianism and catastrophism. And for much of science's history up through to the beginning of last century, things were considered to be the events of catastrophic magnitude, where volcanoes create new landscapes, and meteorite strikes create basins, and floods cover the globe or cover parts of the globe, and then new land emerges. So this was the recognition of how things functioned until scientific observations started to recognize that, well, wait a minute, things are always changing. They're just changing at that imperceptible level unless you take the time to actually measure what's going on. So what is happening out your window right now is geomorphic processes, and they're happening continuously, grain of sand by grain of sand, chemical transformation by chemical transformation. And we can measure sometimes by millimeters, sometimes by feet over periods of time that things have changed. And the process is never ending. And that's uniformitarianism. And it's this continual trend of change. And it's not unlike your school book pictures. So every grade at the beginning of the school year, you had a snapshot taken of you. And by the end of the school year, you may have had another picture taken. And you think, wow, I've changed a lot over the school year. I've grown, all these things have happened. But day to day, every day, you're not noticing the changes. You don't grow 5 inches between grades 3 and grades 4 overnight. That happens over the course of many months. That's uniformitarianism, these small incremental changes that are imperceptible. And with that, when we know that the earth has always gone through these same imperceptible changes that are occurring now, that we are now capable of measuring, the key to understanding the current formations of the earth come to looking at what the past formations were and understanding these very day-to-day processes. And then from that, we can now predict what the future should look like in terms of the Earth's formation. With uniformitarianism, we're looking at very small scale events. Events such as a seasonal river flooding. Every year, the Mahoning River is going to flood in the spring. And the volume of river flooding usually is not significant. We know where the high water mark is. We have engineered our cities to react and absorb and address those high water seasonal marks. And in fact, we go further and we may look at 50-year flood events where it's statistically probable that once every 50 years, a larger flood event is going to take place. And so we want to guard for that. So we engineer our communities for those 50-year flood events. We don't put infrastructure into those environments. We may take risks and say, all right, once relatively every 100 years or so, statistically speaking, we might get a flood that's going to be this much larger. We're willing to take the risk and put some infrastructure into those environments, and then everybody takes notice when those things happen. And so those are those uniform small scale events. They usually only happen in small areas over small time frames. The bigger the event, the less frequent it becomes. When you get to exceptionally large events where they're catastrophic, these tend to happen on larger scales, but happen way more infrequently. So a 1 in 1,000 year flood should only happen statistically speaking, once every 1,000 years or so. That's going to create a lot of change over a lot of area. The earthquakes that we are predicting to happen along the New Madras Fault happen every few 1,000 years. We've housed a lot of energy in that rock structure in and around St. Louis. And because that energy has been building over hundreds and thousands of years, it's going to release a lot of energy. And when you release a lot of energy, there should be a large magnitude of change. And then you get events like ice ages, which only come around every 100 to 200,000 years or so. And then even bigger infrequent events like meteorite strikes. We know that those are going to impact the entire planet. So there is scale relationships that are directly related to frequency. Less frequent small, or pardon me, less frequent large scale, very frequent small scale.